Is my slide up?
Yes, it is.
Yeah.
All right. For the duration of the class, I'll just turn off my video. So this is what I'm hoping to achieve. So we'll go through the slide. I'll take some time, go through the slide, and then I'll also spin up a popular database and querying application that I use, and we'll also run some queries just to give us a look and feel of what it looks like to actually, use this database application. So I'll just be turning off my video for a while. So my name is Sesugh, and today we'll be looking at an introduction to structured query language, which is a language for relational databases. So this is what I'm hoping we'll be able to cover today. We'll start with the boring parts. I'll share a little bit about my learning journey, and then we'll talk about the learning outcomes, the objectives of today's class. Some little tips before we begin. We'll take a look at databases in general, the big picture, where the trend is going, and then we'll drill down to relational databases. And then we'll also talk about data exploration using SQL Server. So I have a bias to Microsoft technology. I'm a .NET developer, and most of my experience has been working with the Microsoft tech stack. So I'll be talking more on, writing SQL queries in Microsoft SQL Server. Even though SQL is a general database programming language, scripting language, let's say, and can be used with so many databases. But what other companies do is they add some flavors to that basic SQL, I'll be calling it SQL from now on, to basic SQL scripting language to be able to enhance their own proprietary application. So we'll also write a couple of SQL queries just so we see how everything works, and then I'll also share some links to resources that we can, read and also dig further. Yeah, so this is just a brief about me. I like to learn. I'm a lifelong learner and a software engineer, like I said. I came into Canada about 3 years ago, and I took a certificate in big data analytics course at the York University, which also gave me a good insight into machine learning and some other data manipulation techniques like using Python and other stuff. So I have a Bachelor of Engineering in Electrical Electronics Engineering. My first opportunity to learn databases was with the Oracle database. I've actually not really worked with Oracle in production, but I did a lot in training. Also have a Microsoft certified professional in querying Microsoft SQL Server, and also have that Oracle certification. So my experience started with mostly working in IT training firms. So right from the onset, I realized that these were a little bit difficult concepts to grasp. So what I did was I realized that if I find a way of teaching, then I'll be able to learn more. So that's how I started out. So I worked with a lot of IT training firms. The popular ones are people in Lagos and Abuja would have heard of First Logic and AfriHub. Then I got an opportunity to work for the Federal Land Revenue Service. I worked there for 6 years, and most of my .NET experience, that's where it started, and that's where I gained a lot of experience working with SQL Server. Then back in Canada, I worked as a .NET developer for a company called Ryan Consulting in Toronto, and I'm currently a .NET developer with Nexus Canada. It's a company that builds research-based tools. It's like the Google for the legal industry, basically. So they have a suite of applications for legal research. In my past experience, I was able to, back in FIRS, I built a tax collection dashboard with a an SQL Server tool called SSRS, SQL Server Reporting Services. Back in 2016, I was part of the team who worked on the recruitment portal then. I worked on a lot of integration projects also. Back then we had integrations with the Nigerian Customs Service, TSA, NIBS, Remita, and my previous experience, or my first experience in Canada, was working on an enterprise logistics management system. We use SQL Server 2016 and ASP.NET Core, which is also a flavor, a .NET framework. So today we hope to have a high-level overview of databases. We'll also understand the different types of databases that exist. We'll understand the concepts of relational databases. Why do we call them relational databases? And, why should we even care? Then we'll also take a look at the structured query language. We'll look at data manipulation, and then I'm hoping that at the end of the class, you should be able to dig in and learn even more advanced concepts on your own. Before we begin, so I'm looking at this more like the prerequisites for learning SQL. Once you can write or even speak English language, then I think you're good to go. And then you should come with an open mind. It might look like an information overload, but on the general note, it's easy. It gets complex, but especially for the data analyst part, I think what you need to know to get your job done isn't so complicated. I also want to share my approach to learning a new skill. Most times, or personally, back in the past, what I tried to do was to be able to grab every little thing and remember every little thing. But over the years, I've realized that really doesn't help much, especially when it comes to programming. And what you need to do is focus on the basics, and then you should focus more on understanding the capabilities and limitations than knowing everything. That's why all programming languages, everything you do, you buy, any item you buy has like a manual or a documentation, right? So we have Google, we have Stack Overflow, which is a popular website for, finding answers to your questions. So if you focus on understanding what the language can do, it's easy to always find resources to, get your job done. And then, of course, getting your hands dirty with practicing. That's really nothing like that. I have an image here to, depict what I am trying to say. And I always try to use this image anytime I'm sharing anything. So I'm sure most of us have driven cars or we've been in cars. And if you look at the dashboard on your car, there's actually a small triangular object with a yellow arrow pointing to in your car. It's only recently did I learn that this actually shows you the direction where your gas tank is on your car.
Yeah.
And I can assure you that a lot of people don't know that. Why? Maybe because you've never needed it. You're not driving a rental car. Most times you're driving your car. So you always know that you're pulling up at the gas station and you know where your gas tank is. So that's how learning a new language is like for me. And not just that, also with open source technology and the current improvements, things change quickly. So you could have gone through the documentation and then designed your application. But tomorrow, something has been added to make the job even easier. But you don't know. But because you think you know it, you don't go back to the documentation to see if there's probably an improvement. So let's start. So I took this off Wikipedia, trying to get a definition for a database. A database is an organized collection of data generally stored and accessed electronically from a computer system. So while there might be many definitions and many types of databases and groupings out there, I prefer to use this tree. So we can have flat file databases, like the Excel sheets we use, like CSV files are comma separated files. They're files with a particular pattern and then they're separated with commas to depict the columns or the rows and records. Then we also have relational database management systems. There are also a lot of them. MySQL is one of them. There's SQL Server, there's Oracle, there's PostgreSQL, there's MariaDB, there's SQLite. There's so many of them. And then we also have NoSQL, not only SQL databases. That's what it's actually called. Because these are This is more like the more recent type of databases that we have. They're referred to as document databases. So the whole idea behind these databases is information is stored in form of documents or files, and they are easily retrievable. So we have examples like MongoDB, there's Cosmos DB, that's a Microsoft DB. You can find it on Microsoft Azure platform. Then there's one called Neo4j. Neo4j is also referred to as a graph database. So graph databases use a graph data structure where there's a relationship between objects, and they are called nodes, and then they have like relationships. But if you look at the map down here, the green arrow is where the path we're going to follow today. So we're starting with databases, and then we're going to focus on relational databases. Then under the types of databases, we're going to focus on SQL Server. And then even in SQL Server, even with writing SQL queries, there are different types of SQL queries. There are data definition languages, data manipulation language, data control language, and transactional control language. There are even a lot more, but I think these are sufficient and will make also drive the point home. So just some keywords or some buzzwords that we might come across using the relational databases. So I thought I should just bring them up while we go through the course. I would also talk about them. I'll mention. We'll come across them while we discuss further. So relational databases basically store data in tables, and these tables can be related to each other. We'll get to that. And tables are referred to as database objects, and they consist of rows, columns, and then relationships. So the table is just an object in the database. There are so many other objects, like we'll get to see as we move along. And but our focus is more on tables as a database object. So columns hold specific data types. So like string, numeric, we can have date and time, and then so many others. If you've used Excel, it's just about the same thing. The columns are the letters in our Excel sheet, and most times they hold a particular information. You can have a first name column that holds everybody's first name in that database. You can have a last name column. You can have a date of birth column that holds, a data type. And then for rows, which are also referred to as records, can hold information about an observation, or let's say a person. If I want to find out information about a particular person, then I'm querying that row. If I want to find out information about all the date of births, then I'm querying that column. And then database also contains other database objects. There are stored procedures, there are views, there are triggers, there are synonyms. If we have time, we can talk briefly on those. Then information about data stored in the database is usually referred to as metadata. And metadata is, so you're storing information, right? You know that the date of birth is a data type. And all that information is also stored in certain database tables. Then the database schema is like a blueprint of how your database is organized. We'll see more about the schema when we go into working with databases. And then relational databases. So tables can have constraints which are used to specify rules for data in a table. So constraints could be at the table level, or let's say at the column level. So these are some of the popular constraints that we will come across when we're using database tables or we're defining our tables. One is called the primary key constraint. All this does, it enables you to uniquely identify every record in a database. Then we also have the foreign key constraint. So what it does is it references the primary key column in a related table. Sometimes we can have a one-to-one relationship. We can have a one-to-many relationship. We'll see more of this in subsequent slides. Then we also have a unique key constraint. And what the unique key constraint is, just a rule saying that you cannot have duplicate values in the column. The primary key constraint will not allow you have duplicate values also because it uniquely identifies that column. But sometimes you want an extra column to not hold duplicates. And then there's also a composite key constraint. We'll talk about composite keys can have 2 or more columns. So let me put it this way. You can have a similar 2 or more columns are combined to form like a primary key. So you can have a combination of those columns. You can have duplicates of a combination of those columns in your database table. And then databases also have a concept of the not null constraint. So, or the null constraint. So what this does is, in a database, an empty string, even when you in computer programming, empty string is actually a character, right? So if you're filling empty string into a field, you actually have to type it on the keyboard. Space is also a character. But the not null, the concept behind not null is telling you that the column cannot have an empty value. There has to always be something, even if it's space, then it's a value. Even if it's an empty string, then it's a value. So if you say a column is not null, that means if you're inserting data into that database table, then you must always input a value for that column. The check constraint is used to limit the value range that can be placed in a column. Sometimes you're designing your database and it's for adults, so it's 18 and above. You automatically don't want to insert any data, or you have an age column and you don't want to insert anything below 18. You can actually add a check constraint at your database level. So the image we have here is just a scenario trying to explain the different ways that we can get information into our databases. So written here that data can be added to the database through application forms, like what we have here, through APIs. APIs are application programming interfaces. They are like programs that don't actually have a user interface. And then it can also be added directly using SQL queries. And also you can do bulk inserts from Microsoft Excel or other flat file sources, as we will see as we proceed with the class. So I have this concept here to give us a big picture of how applications work with databases. So on the left, there's a form. And in that form, we have a title, a first name, middle name, and all that. So you go online and then you fill the form online. You fill that form and then you click on your submit button. So what happens behind the scenes is the application developer writes the code that collects the information from that form and then goes through certain processes. So there's a business logic layer that manipulates or validates that data, and also checks to make sure that the data meets the criteria that your database has been designed for. So you can do validations even at the client side, you can do at the server side, which is at your back-end code, and then you can do validations at the database. All these 3 validations help protect the data integrity of your data. So on the right here, I have 3 database tables that this information will be fed into. The first table is the customer table. If you look at the first row, I actually pulled the exact data. We have the title, the first name is catering, and then we have the middle name. So this person was filling the information for catering. And once you fill in that information, once it passes the validation, there's an insert SQL query in the programmer writes inside the application that then inserts that data into the table, right? And the same thing happens for all the other records. So this is my first attempt at explaining what relationships are. So if you look at the form, we have a field called the address field. And then I have a link there saying add another address. So sometimes you go online to a site and they ask you to add, maybe you can click on that and then it brings up another form for you to fill in the address. So you have about 3 addresses for a particular person. How do you insert those addresses into the database? One of the options will be to create a column, address 1, address 2 in your customer table, address 3, address 4. But what if you don't want to limit the number of addresses? Because if you have 4 columns, that person can only add 4 addresses. What if you don't want to limit the number of addresses that person can add? So there comes in the concept of joins. So if you look down below, I have a separate table called the address table. So here I could have so many addresses, but how do I relate the address to that particular customer? In the middle, I have something called the customer address table. This is referred to as a join table. If you look at the customer ID column for catering, we have 29485. Then if you come to the customer address table, we also have the customer ID as 29485. Then we have an address ID of 1086. If you come down to the address table, we have an address ID of 1086. So the column in the middle automatically relates the customer table to the address table. And why do we have a table in the middle? Because this customer could have a second address, and the second address could be ID 1086. So if the second address is 1086, then in the customer address table, we'll have customer ID 29485 as a second row, and then address ID 1087. So this will automatically relate that this customer, because this customer ID has more than one address, so you'll be able to pull that data. So this is where we talked about composite keys in one of the slides at the behind. So in this customer address table, I can decide to make customer ID and address ID a composite key. The whole idea is I don't want to add the same person with the same address twice. And then going further, two customers can actually live in the same house and use the same address. In that case, your join table helps, right? So it's called a many-to-many relationship, because a customer can have more than one address, and then more than one customer can live in the same address. So, that's generally the concept behind a many-to-many relationship. So relational databases. A diagram showing how the tables relate is called an entity relationship diagram. And the process of breaking down tables into discrete chunks or entities is called normalization. So normalization is a concept. So it has the first normal form, the second normal form, the third normal form. We won't go into that. It's something you can actually read about. It's quite straightforward. But like I explained in the previous concept, you can actually have what, more than one. You can actually have more than one address column in your employees table, but that would not really be efficient. And then some of the benefits of using relational databases is it reduces the storage requirement by avoiding data repetition. Just imagine that you had two people using the same address and you had an address column in the customer table, then you will have address and then address. Then also it enhances data integrity. In the data, just imagine a scenario where you have an employee. Let's say you have a customer table and then you have the address table. Anytime you delete the customer from your application, you want to be able to also delete that address. So with that relationship, you can, while defining your database, there are options. You can set that anytime I delete a customer, delete all the addresses. And that helps with data integrity. If you're using an Excel sheet, imagine that you decided to change the name of a department. You have a department's column in your table, you have employee name, you have to go and make sure that every column name has been updated. And some of the drawbacks that comes with using relational databases, it can actually get really complex. And then sometimes there's redundancy when storing information with different requirements. Sometimes, let's say you have a table and you're storing a product table and you're storing information about items. You have a column for color. And then you have items you're selling. You're selling a shirt. Yeah, it's nice. A shirt can have a color. But what if you're selling a pencil? Or you're selling something that really doesn't matter, or size? The shirt will have a size, but your pencil will not have a size. So when you're designing database tables and the columns, that will have to be like an empty field, because the column does not have your pencil, for instance, does not have a size. And that also, so that's one of the reasons why we have NoSQL databases. The concept behind NoSQL databases is it's dynamic, so you can actually store any information without being restricted or to columns and tables and data types. So I have here before us an entity relationship diagram of some of the tables we'll be taking a look at. I'm looking at the time, so I'll probably be speeding up a little more. So we have the customers table, and then we have the customer address, and then the address table. So we've talked about that, and we've talked about how these tables can relate. Then if you look at the customer table, the customer ID is the primary key. And then in the customer address, we have the keys beside customer ID and address ID. So it's acting as a composite key. Then in the address column, we have the address ID. Then the second column, we have the data type. So data types are just telling you what kind of data can be stored in that column. The nvar is referred to as a variable character. So it's just for storing text data. Then below, we also have something called a product table, and then we also have a product category. So here we have a one-to-many relationship because we have a category and they want to have products under that category. So we have a product ID. If you look at the product table, there's a product ID column. And that product ID column is what is related to the product table. So if, for instance, I want to change the name of a product category, all I need to do is go to my product category table and change the name. And then, because they still have a relationship and they have a relationship with the key, anytime I query my product table, I will see the original name. Imagine I had the product category name in my product table. It will be a Herculean task having to, make that changes to all the rows, and data integrity would not be guaranteed because you could miss out something. So now let's dive into SQL Server. So we've talked about databases in general. We've talked about the relational databases. Now we're talking about SQL Server database. So Microsoft SQL Server is Microsoft's database or relational database for querying and for storing and retrieving data. So the Microsoft SQL Server has its own flavor of SQL. So the basic SQL is the same, but sometimes, like I explained, these companies add a little more syntaxes and functions to enhance functionality. Everybody's trying to sell their product, right? So they will try to create things that will make it even more catchy and easier and friendlier for users. So the SQL Server has, SQL Server installed has four main components. There's the database engine. I'm highlighting that in blue because this is where our focus is. There's also the software comes with an SQL Server integration service. It's just a tool for integration. So it's really cool. You have like drag and drop tools where you can actually specify different data sources. You can create a form of automation. An example can say, okay, there's an Excel file that is dropped in a particular folder, and you create an automated script or workflow that goes there, checks for that Excel file, picks it up, retrieves all the data, inserts it into a SQL database. You can be checking every 10 minutes, you can be checking daily, you can actually schedule it with however you want. The SQL Server Reporting Services is a tool for creating reports and dashboards. Also a really cool tool. And then SQL Server Analysis Services is for data analysis. I personally haven't really used that much, but this is the suite that comes with SQL Server. And then SQL Server Management Studio, which we'll be using, is a Microsoft IDE for managing SQL Server databases. So an IDE is also referred to as an integrated development environment. So what it does is it makes the job really easy for you. You can actually write queries using the command line, but just imagine how difficult that could be. So personally, I like the easy way out. So for any time, anything I'm doing, if there's a tool that will make the job easier for me, I would always use it. So we'll be taking a deeper look at SQL Server Management Studio. So SQL Server Editions and versions. So SQL Server is mostly named based on the years they have been created or the improvements. So over the years, we've had SQL Server 2008, we've had 2012, 2014, 2016, and currently I think we have 2019. To be honest, most companies still use 2014 and 2016. But what this do with every year, there are enhanced features to make the job easier for the developer. So for me, it's even easier to be a developer now than even before, because what the company's target is what tools to make the job easier for you. So for SQL Server editions are the different packages, right? It's quite an expensive tool, but they want to be able to sell to the different type categories of people. So there's an enterprise edition which comes with all the package, SSIS, SSRS, and it's fully managed, large storage space. And there's a standard edition that can be used for smaller companies, and it's of course less cost. Then there's a web edition that I use. Most hosting companies use SQL Server Web Edition to be able to provision for websites and applications that people build and deploy online. Then there's the SQL Server Express. Express is a free version of SQL Server. You can Google it, you can download it. The basic installation process should be quite straightforward. And it's also used, it's a smaller tool, less storage space. I think doesn't come with SSRS and some other tools, but for the purpose of data analysis and all that, it's a tool that can serve. SQL Server over the years has also, can also be installed and deployed on Linux operating systems. And we're familiar that Microsoft is actually a Windows tool. So we're going to take a quick look at writing structured query language. And what I'm going to do here now is I'm going to go over some of the syntaxes through the slides, and then I'll spin up the SQL Server Management Studio, and then we'll try to look at some of the commands that we've been talking about. So in SQL Server, we basically have data control languages, and some of the keywords or the syntaxes that I use, that grant, revoke. What you can do is, in a database, there are actually users that can use the database. So you can create permissions for users to use these databases. So these are some of the commands that you can use: grant, revoke. Then there's also data definition language. So you use to create and manage database objects. Like if you want to create a table, you can use the create syntax. You want to make changes, add a column, delete a column, or add a constraint, you can use the alter syntax. You want to remove it, you can use the drop, remove that table completely, you can use the drop syntax. Then there's also a data manipulation language, which is more like our focus for today. We have the select, insert, update, and delete. In programming, we also refer to this as the CRUD operation. These are the basic operations you need to do with the database. You want to retrieve data, you want to put in data, you want to make changes to that data, and you want to delete the data. So we can look at the delete and the drop. The drop removes that object completely, while the delete removes data, but still leaves the objects intact or the structure intact. And we also have transactional control languages like begin tran, commit tran, rollback tran. We might not get into that today, but sometimes you're writing some SQL insert scripts. For instance, I want to insert a customer, and then I also want to add the address into the address table. With the transactional control languages, you can specify where your transaction starts, and then if you can insert into the customer table and then try to insert into the address table. So if for any reason that fails, you want to be able to roll back the entire transaction, right? So you can group them into using transactional control languages so that all your SQL queries, it's either they all work or none works. These are things for data integrity purposes. So this is how simple, like I said, writing these queries, all you need to do is with time, you get used to the syntaxes, but it's plain English language. So this is just an example of what a data definition language statement is. Create table, then you put down the table name department. You open your bracket and then you start specifying the column names. It can even be on one line. It can be on separate lines. It's just for formatting purposes. So I want to create a column called department ID. And then the data type will be an integer and it's going to be the primary key. I'll put a comma. I'll say department name as an nvarchar. That's a variable character data type. And I want it to have a maximum of 250 characters. That's it. You run this query against your database and you create a table. The second table here we have is create the employees table. Almost the same syntax. The only thing here we have is we have a department ID column, right? And we have the data type as int, and we said it's going to be a foreign key, and it's referencing the department ID. Sorry, but yeah, it's in the department table. So it references the department table and then the department ID column. And then we also have something said on delete cascade. So there are other options: on delete set to null, and then there's on delete. They shouldn't do anything. They don't do anything. So what it's saying here is anytime I delete an employee, or anytime I delete, sorry, a department, then I'm getting rid of all the employees. So this all has to do with your design, how you want you can say on delete set to null. So what is going to happen is if you let's say delete a department, instead of deleting the employees that work in that department, it will make them departmentless by updating the data in the employees table, that field to become null. So these are some of the design concepts that can be used in designing databases. This is a sample DML statement. This is what we're going to be looking at more. So for writing for the DML statements, it's still also English language. Select employee ID, comma, last name from employees, where employee ID equals 1. The other syntax here uses a join table. And then we have what select asterisk. Asterisk is referred to as a wildcard in SQL. And with asterisk, you can actually say select all the columns. Imagine you have 50 columns in your database table and you don't want to pull everything, or you don't want to specify with the comma like we had in the first instance. You can use the asterisk. And then we have from employees. And then here we're using a joint syntax because we want to get the department also. So after employees, I wrote a letter E. It can be any letter, but it's referred to as an alias, right? And then we have join departments, and I use the alias D. On department ID equals D dots department ID. So you can actually say on employees dot department ID equals department dot department ID. But the alias helps us to, make our query neater and then write it shorter. Then we also have the where clause, where last name like, and then we have a quote. And under that quote, we have an underscore. This is also another wildcard. The underscore simply means one character. And then the first character can be anything. So you can have a name like Desu. I use this is my name, Sesugh. So you can pick any character, and then, but the next character after the first character has to be E, S, and then U. Then the percentage sign is also a wild character saying it can be as many characters. So the underscore is one character, while the percentage is one or more characters. We'll see that in practical when we use to filter some of the, when we're writing the queries. So these are also some of the syntaxes we can use. We can use the where clause, which is used to filter rows based on the value. We can use a case statement. We'll use the having clause. There's an order by, which is used for sorting. There's a group by, which is used in aggregation. Then there's also using joins. I'll run through these because we're going to come back to these when we start using the practical. SQL Server uses a lot of comparison data. Then it also uses some set syntaxes like union, union all, intersect, except. We'll take a look at those. There are also conditional statements. And then there are logical. We also use logical operators, and then we use math operators. Then this is some other wildcards we can use. Here we have the percentage sign, which means 0 or more characters. For instance, I can have BL with a percentage sign. So it's going to find black, it's going to find blue, and it's going to find blue. If I have the underscore represents a single character. So if I have H with the underscore T, then it's going to find hot, heart, and heat when you run your query. Then the bracket represents any single character within the brackets. So for instance, I have H with the square brackets, I have O, A, then T. Then it will find hot, it will find heart, but it will not find heat because we don't have I within the square bracket. Then the caret sign basically negates the values in the character. So if I have a caret sign, then it's going to find heat, but it will not find hot or hot. So it's more like mutually exclusive with the previous one. Then the hyphen represents a range within the square bracket. So it's going to, if you have A to Z there, then it's going to pick any character between A and Z. And then the asterisk returns all columns. Let's briefly take a look at understanding joins in SQL Server or in SQL generally. So we have inner joins, we have left join, right join, and then we also have a full outer join. So if I have the employees table and the departments table, for instance, and I do an inner join, then it's going to return only where it can find data in both tables. So it's going to return only employees that have departments. But if I do a left join and my employees table comes before the departments table, then it's going to return all employees, even for those that don't have departments. For the fields where it should provide the department, it will have none. The full outer join brings in everything, including departments that don't have employees, and then employees that don't have departments. Then the right outer join is basically the opposite of the left join. So SQL Server also comes with some built-in functions. So in programming, functions are just constructs that it's the basic structure of programming, any programming language. It can take data or not, and then sometimes it just performs a particular, function. So length, for instance, and most times functions have brackets. After writing the function, you put whatever data you want to act on in the brackets. So length, for instance, will return the length of that character. We have L trim, we have R trim, can trim empty spaces at the left or at the right of your data. We also have substring, we have car index. We can rush up to, then there are aggregate functions also, average, sum, max, mean, count, that can be used. And most of these are then also date time functions that can also be used. So data exploration using SQL Server. So I'll quickly spin up my SQL Server Management Studio. And we can get to writing a few queries. I don't know if we want to stop for some questions, or we can do that at the end. How much time do I have? So this is what the SQL Server, Microsoft SQL Server Management Studio interface looks like. It's quite plain, it's quite simple. And most times I prefer my users focusing on data manipulation language, because these tools help you to do a lot of things that ordinarily you would not be able to, or ordinarily you won't stress, like creating a table. You can actually create a table using GUI interfaces without having to do a drag and drop. So this is under the database expansion. This is some databases that I have on my system. I'm going to use the training database, and I took the liberty of creating some tables. Based on the diagram I showed us, we have an address table, we have a customer table, a customer address table, the product, and the product category table. So these are some other database objects like I explained to us. We have views, we have synonyms. Under programmability, we have stored procedure. Then functions, you can also write your own functions. So I'm querying the database can be quite easy. I can right click on the table and then say select top 1000 rows. What this does is it brings up that information and then you can write. So you have select top 1000 customer ID. You can take this out. The square brackets, you don't have to put them if you don't want to. And then this is signifying the database. This is signifying the schema that we talked about. The schema is just all the tables are organized in the DBO schema. And then this is the table name. So most times, if you have your here at the top, we have the database selected. If you have the database selected, then it's quite easy. You can actually write your syntax without. Now see what's happening. The ID is giving me IntelliSense, telling me that I can actually select the customer. So this is actually about the same thing which we have done. I'm using the asterisk syntax because I want to pull out all the columns from the database. And just to chip in about writing SQL queries, I had the opportunity to learn a little bit of data science and machine learning, and I realized something. The machine, if you're using Python, you're using any application, most of the functions where you pass in your data to create your output have already been written. The major work in data analysis and machine learning is data preparation, trying to get your data ready for to feed into those applications that will generate the outcome. So most times you can do some of those things in Python, but with SQL Server, this is actually an engine that is designed to handle large records of data. So you can bring in your data here, do a quick cleanup, and then push that data into your any application you're using to manipulate the data. So select asterisks from customers can give us this information. So if you want to filter by columns, you can actually select what first name. I still have my IntelliSense. So I can say select first name, comma, last name from customer. And it gives you just those things. So you can filter by column. And you can also manipulate your data by column. What if where you want to feed your data just has one column for name? You can actually use a concatenation syntax. The plus in SQL Server enables you to concatenate. So what I've done is I've concatenated three things here. The first name, I use the plus, then I use an empty space just to separate the first name and the last name. And then I use the plus and then the last name. If I run this now, sorry, could not find the stored procedure last name. Sorry. So if I run this now, it's giving me the first name and the last name. But if you notice, there's no column name. So I can also add an alias. You can use the ASCII word, and then I can say full name. And if I run this, it's going to give that column a full name. So these are some of the manipulations you can do with your columns. You can manipulate your column data. There's a lot more you can do with your column data. Let's say we come back. I want to create, let's say, a username for my application. I want to add a column for a username, or we want to generate emails for our users, and then we can say I want to pick just the first letter and then the last name. We have a function called substring, right? Substring, and then let me do this. So I have substring, and then I want to open my bracket. You can see that it's giving me IntelliSense, telling me the expression, starting position, and then the length. So the expression I want to use is first name. I'll put a comma. I want it to start at the first character, and then the length, maybe I want it to be just long. Then I can concatenate it with my last name. Maybe I want to create a username. If I run this, you can see that we have the first name concatenated with the last name. There's so many, and you can actually mix functions. So maybe I want it to be in lowercase. I can actually say lower on the first name and do this. Or I can even say lower for everything. Let me see if this works. You can see that everything inside the brackets will end up being in lowercase. So there are a lot of functions. If you go back to the slide, we might not be able to touch all those functions, but these are numerous ways that you can manipulate your column data. Then your row data, all you need to do is add the where clause. And then you can specify, okay, let me run without the where clause just to see. Are you looking for a particular person? Are you looking for a particular ID? Sometimes maybe you don't want to use you want to remove anyone with some null data, people who don't have middle names, or you want to replace it with something, right? Or you can say where middle name is null. So it's null or equals to null. Let's run this and see. So you see that it's returning only the data with the middle name null, right? There's so many things you can do. You want to replace, there's also a function called is null, where you can, so you're saying that expression, if the middle name is null, sorry, then replace it with something. This should be single quotes. So you can replace it with no middle name. So let's take this out and run this. Sorry, it's no middle name. Let's check. Let's look at our IntelliSense again. It's null, the replacement value. So the null middle name. Oh, sorry. This is it here. It's an extra column, right? So for all those who don't have middle names, I replaced with no middle name. So these are some of the function things you can play around with in SQL for row filtering. So you can also use wildcards like we talked about. So I just wanted to ask quickly, how much time do I have left so that I'll know, so that we can leave room for questions?
Yeah, but is it okay to ask a question before you jump out of this?
Or please do.
Yeah, so I noticed this operation that you just did. And,
yeah.
So would there be another syntax to actually make it replace that column instead of adding another one? Is it, would it be okay to just,
yeah, you can do that. So what happened here is I'm using asterisks, right?
Yeah.
In this case, you will not use asterisks. You will use customer. You have to call out the columns, right? Customer ID,
yeah,
first name, right? Last name, and then last name, and then when you get to middle name, then you can use the is null function.
Oh, okay.
You get the idea.
Yeah.
So
sure.
you can say is null, then middle name, comma, and you can have anything. So this would work.
Oh,
right?
Perfect. Okay.
Yeah.
Sure. Nice. Thank you.
Yeah. So let's so we've talked about substring, we've talked about some of the column and row filtering. So SQL Server also supports aggregate functions. So sometimes you want to group your data, right? A scenario here, we have a table called customer addresses. Let's see what we have on that table. So customer addresses actually have It's what we refer to as a join table. So it has the customer ID and it has the address ID and then the address type. So now I want to see customers and their addresses. So let's start with that. So I say select asterisk from customers, okay, from customer, right? And then I can give it an alias like we talked about, C. Then I'll do a join. To join, it's called the address, customer address, sorry. So I'm going to join the customer address. I can give it a name, CA, and then you're telling us how are you joining them. On C dot customer ID equals CA dot customer ID. So with this, you'll be able to get, because I'm using asterisk, it's going to return the output from both tables, right? So we have the address ID, we have customer ID twice because we have it in both tables, right? So we have customer ID, address ID, and then the address type. So what if I want to actually get the actual address? Then I can do a further join. So now we're going to join with the address table, and we can give it an alias A. And then we say on, so that we'll say on CA dot address ID equals address dot address ID. So let me see if this helps. So address is like a keyword, and oh sorry, I can use A instead of using address because I created an alias for it. But I can actually use address too. And if I execute this, now I have all the data, right? I have down to the customer. I have the address, city, state, province. So it's quite, it's quite easy doing the joint. But when you're doing the joints, you need to, where the left join comes in. So join does a basic join. So what the join is doing is only customers that have addresses will be returned. But if I did a left join, then for customers who don't have addresses, we'll have like null in all the fields here. And if I do a full outer join, then it's going to still return addresses. For addresses who don't have customers, this part will be null. For customers who don't have addresses, then this part will be null. And for those who have, will have this full information. That's like the general concept behind using join queries. There's so many keywords. Sometimes your boss might say, okay, how many records do you have, right? So we can do a select asterisk from customers, from customer. And we can actually get, if you look at the bottom right corner, you can see that we have 407 rows. But what if you want to actually get the number? You can do a select count. It's also an aggregate function. Count asterisk. Count asterisk from customers. This might fail. Okay, so we didn't fail. So we have 407 customers, right? So there are a lot of, and like I said, let's say customer addresses. Let's look at customer addresses. So from customer address, I want to be able to, your boss will say, okay, I want to be able to see customers that have more than one address in the application. So in this case, you're looking for two, the whole idea is you want to see the customer ID. That's the first thing. And then the next thing is you want to count. Count customer. Or is it count address ID? It should be count address ID. So you want to count the address IDs for this customer. So this will fail. And the reason why it will fail is because it's telling you that this is you're using an aggregate function. Here we had only one column, but here now we have a second column. So we actually need to use something called the group by column. So we're going to group by customer ID. Think about it, right? It's logical. We want to do a count, so we want to group by customer ID. Right, so now we can see that this customer ID has 2. This customer ID has 1. This customer ID has 1. Then maybe your boss says, I want to see those that have only 2, that have only 2 this thing. So initially we were using the where clause, if you remember, to filter, but when you're using aggregate function, you use something called the having clause. So you can say having count address ID greater than 1. Let's see if this runs. So this returns the customers that have just 2 address IDs. So in overall, we've taken a look at the select statement. We've looked at the from clause. We've also looked at the where clause, right? So we can say where. But when you're using aggregate functions and you're doing a grouping, then you have to use the having clause after your group by clause if you need to filter by the row. So and there's so many things. Yeah, one thing I also quickly wanted to show us, one is SQL Server also has a functionality where you can actually import data. So you're a data analyst and you have a data in Excel you want to quickly clean up. If you come to the database level, you can right-click on tasks and you can come there. We have import flat file. If you want to import a CSV file, you can use that option. Then import data. Let's say you want to import an Excel file. Once you do this, a wizard comes up. So it's quite easy and straightforward. Here, you're going to select Microsoft Excel. You click on your browser and then I want to pull in this data. Select it and you pull it up. This checkbox saying first row has column names. Sorry, I should have shown us the Excel sheet, which I will do after the import. Click on next and then destination. Where do you want to send it to? Microsoft SQL Server native client. That's what the database is. This is the name of my server. Most of this will be default. The database is the training DB. And I can do copy from one or more rows. It's quite straightforward. Here I can give you the name. This is the name of the table I want to pull the data into. Let's call the table costs. You can even click on edit mappings to see the columns that have been pulled from that table. And then you can click on next. And then here we have save as SSIS package. We talked about SQL Server Integration Services. All it does is you can save it so that you can actually run from time to time, however you want it. So we have 407 rows. If I come to my training database and I refresh my table, I refresh my database, here I have the cost table that I actually pulled that data from. If I come to, where did I save that? So was it in documents? If I open the Excel sheet, you can see that it's about the same, it's the same data that I have in Excel that I pulled into SQL Server. So it's quite easy pulling in your data from the different sources. You can pull from CSV, you can pull from Excel, and SQL Server also has something called union. Those are so I can say select. Just imagine I have data from different Excel sheets and I want to merge them. So I can say select first name. Most times, if you put the asterisk from, now that brings me to a point. SQL Server is not really like other programming languages, right? It's quite unforgiving. Depending on the collation of your database, in most cases, it's not case sensitive. So my from clause, I can put that and it will still pick the value. So let's say I want to do last name. I want to do last name from customer. I can have it on the same line if I want to. So this is picking the last name. I can do a union. Union is going to union, and I'll say select. The thing now is okay, let's use the product table instead so that we can just have I can do a select top 1000. I can say select name from product. So if I run this query, what it's going to do is it's going to name the column last name, and it's going to pick everything, including products, from the product table. Can you see that we have the product names also? So that's how union works. Union selects, brings only the distinct values. But if I do select last name from the new table we added cost, the new table is actually the same with the upper customer table. This is underlined. I think it should still work. It's because I just added it. So if you can see, we have 367 records. What it has done is it's only picking unique records. So it's going to compare both records and anything that is unique. But if I do a union or, then it won't matter. It's going to pick everything, 814 records, even if they are duplicates. In SQL Server, there are also certain things we can do, like just to give us a tip, there's something called common table expressions. No, I think we don't need to go into that, but we can also use intersect, and then intersect just picks what it has, what's familiar with, what's the same in both columns. So if I have an extra name in, let's say, the cost table, then intersect will not pick that because it's only found in one of the tables. So the criteria for the union is the number of columns. You can do more than one column, right? You can do first name and then comma first name. So you can do this, but the columns must always match. So if you have 3 columns here, and the data types must match. So for instance, I can't do, I don't know if phone number has the same data type, but okay, let's say customer ID. Do I have customer ID? I think I had a column called. So while this is not happening, it's because it's a new table that I've added. So I can come to this place and refresh local cache. So the data types must match. For instance, I have last name here, and this is last name. It's going to pick the name of the first column in our output, and then the data types must match. So if I have something that's an integer data type here, for instance, I have customer ID, this query will fail because this is an integer data type, this is a string data type. So if I run this, it's going to fail. So that's basically some of the rules that come with SQL Server. I would also, so there's a lot. There are a lot of syntaxes that you can use. SQL Server has something called the case statement. In data analysis, sometimes when we're preparing our data, we do some form of binning. For instance, you want to categorize prices. So let's say in the products table, we have a price, but in our machine learning model or wherever I want to use our data, we want to be able to categorize our prices, right? So we can use something called a case statement. Let me say I can have name. Let me even have the list price. And then I can have a comma. All this can be on the same line, but most times it's neater. So I have a case, right? And then in my case statement, I'll say when list price is less than, let's say, 1,000, then I can put it in the category of 0 to 1,000. Then I'll add another when. I can say when list price is between, let's say, 1,001 and 2000, then you can do this. Then you usually end your statement with an else, like a default value. If it doesn't meet any of that criteria, what should happen? So I can say else greater than 2000, and then I'll say end. So this is just for the syntax. Look, I can give it an alias as price range. So let's run this to see if it works. So if you can look at this now, we have a price range column, and then we have list price. So there's a lot we can take a look at. There's so much we can do. SQL Server also has date time function where you can manipulate dates. I think this will be the last thing we'll talk about so that we can leave room for questions. So get date by default brings your current date and time. And you can also add a year. The year is also a function that you can pass the get date into just to give you the current year. (2021), and there's so much you can do with SQL by playing around with it, taking a look. But the basic thing about SQL and writing SQL queries is your select statement, your from statement, your where clause. Once you have a basic understanding of how these things work, then it's always easy to be able to pull forward. For being conscious of time, I think we can put a pause so that if there are questions, we can take them. And yeah.
Thank you so much. That was very insightful. Can we show appreciation to the speaker or the teacher this evening on the chat? Like thumbs up if you felt like this was very insightful, and any emoji will be, that would be great. Thank you so much. Thank you so much.
Yeah, and let me go back to my slide. So if so these are some links to some resources that I think will be useful with learning SQL. You can Google, you can use Stack Overflow. There's a lot of resources on YouTube, and there's an app. If you go to sololearn.com, the cool thing about this is there are mobile apps you can actually install on your phone, and play them like games. And it's cool because you can always carry it along with you. w3schools.com is a popular website. It's more like the documentation for the web applications. And then tutorialsteacher.com is some of the sites that I've used over time and I think are really cool for beginners and even experts. And yeah, I would appreciate any feedback on areas of improvement. Thank you.
Okay, sorry, just a question. Sorry, when did you finish from York University?
That was in it was just a 6 months program. That was in 2019. Yeah, it was in 2019.
Okay, were you taught by Rick Lambroff?
Rick Lambroff? I don't think so. No.
Oh, okay. Okay.
Yeah.
Okay.
I have a question. Oh, okay.
Okay,
yes,
yeah. Just a quick one. Sorry. Let me just organize things here. Please, if you do have a question, signify by raising up your hand, and then so we have an idea of the number of people that have questions to ask, and then we can then tell you to unmute and then ask your question. So I didn't get the last person that wanted to ask a question. Can you signify by raising up your hand, like on the using an emoji?
Yeah, I just did.
Okay. Sunday, please go ahead, ask your question.
Yeah, so great presentation. I like that, of course, you actually broke it down like right from the basics. I just wanted to ask you this. So I work with, database where people, like we get data from every sources, and then people use slangs. So one of the challenges I have, okay, I'll just give you a scenario.
Yeah.
So I have a myriad of data, and I want to pick a word like, say, transmission, for example.
Okay.
And this is a data where, somebody can call it trans, somebody can
Yeah.
call it tranny, somebody can
Yeah.
call it transmission. But at the same time, I don't want the data to pull transmitter for me.
Yeah.
You know what I mean? So
Yeah.
how do I don't know if there's anything like an intelligence that the SQL has that I can achieve that.
So I'm trying to get back to, you can use it all has to do with your imagination and creativity, right?
Yeah.
Because you can use my screen is visible, right?
Yeah, sure, I can see it.
So we have wildcards here. So
Yeah.
in your where clause, you can see the option here. For this, the third row.
Okay.
With the square brackets, it represents any single character within the brackets. So for instance, if I have H with the square brackets OAT, then it's going to find hot, it's going to find hat, right?
Okay.
But it will not find heat because heat is not within the square brackets. And then if you use the next line, if you use the caret sign, it's going to negate. So you don't want translate.
Yeah.
You get the idea?
Yeah.
So it's about your creativity and playing around with what you want. So you can use that to also pull the data. Yeah. And then, so it's about it. You can manipulate down to very fine filters with this syntaxes. And you don't need to know them. You don't need to remember them. You just need to know that they exist, so that it can help your work. You can always go to the documentation, get them, and use them. Right? Yeah. SQL Server also comes with a function called soundex that I've used before. So soundex actually tries to pronounce those words and picks words that sound like that.
Okay.
Yeah, I've used it before, and it's.
Did you say sound? How do you spell that?
Soundex. Sound, then EX at the end.
EX. Okay. All right.
Yeah.
Okay.
Soundex,
Thank you.
Yeah. So you can check that out too.
Okay. Perfect. Thank you.
You're welcome.
So someone was actually asking me if you could go back to the second to the last slide. She just wants to get the person just wants to get the list of the learning resources for.
Sure.
Yeah. Okay. Do we have any other questions?
I'm not seeing any. Adidiji, Andrew, Koflax.
I'm sorry. Osita, can you make me kind of like a co-host?
Yeah.
I don't have visibility on my side. Please go ahead. Thanks. Go ahead.
Me, Koflax?
Yeah, okay, Koflax.
Oh,
you can
okay.
Go ahead, yeah.
Hey, thank you, Sesugh, and this was a great session. I really like it. And just a comment also, I work with Sesugh, he's great, and I joined this because I always learn from him. So my question will be basically, will it be in a session for this as a follow-up of the next step deeper of like the databases, or this is just the beginning, just this will be the end of it? I would love to always be here because he's a great guy. I always learn from him. So that was my question. Thank you.
Yeah, I think Josh, you should be able to answer that, or even Osita will probably talk about that.
Osita, do you want to go for that? It would be definitely nice to have you back. So I thoroughly enjoyed the session. I like the way you broke it down. I wasn't sure what to expect in terms of, I know it's technical, right? But you broke it down and you made it very, very simple to understand. So definitely, depend on the feedback from the community, etc. We might definitely see you coming back and just doing some more of this. I don't know if that's in line with you, Osita. But in the meantime, we can take another question. Why?
Hello, can you hear me?
Yes, we can hear you now.
Oh, okay, fantastic. Great session, Sesugh. You've done a great job, obviously. Again, most members will confirm, in terms of a session like this, especially for beginners, some beginners will be seeing some of the component of this session, like Chinese language, that kind of thing, right? They'll be looking at it and they'll be like, wow, how is he able to do all this and all those kind of things? So typically for SQL, especially for beginners, really, a session like this is not going to cut it for them, right? I think we had that conversation, Sesugh, right? Where we'll probably need to promote this to an incubation program, that's going to run through a couple of weeks. I think that will really be very, very, very impactful, for many members of the community, especially those that have seen themselves using SQL in their place of work, those moving into data science, data analytics, and the likes, right? Yeah. So obviously, we're going to, have further conversations. And see possibility of promoting this for incubation program that is going to run a couple of weeks. I think that will really be helpful, because sometimes if you're a beginner, even if you have all the links in the world, some things might not just make sense. Sometimes you just need someone to be able to, hold your hand along the way. So yeah, so that answers that. In the next couple of days, guys, you should expect communication in respect to the incubation program on SQL. Okay.
Sounds good. Sounds good to me.
Can I go ahead? Yeah.
Yes, Adedeji, please go ahead.
Thank you so much. Thanks, Sesugh, for a wonderful session. It was really very impactful. I have two questions. One is, in your experience, which flavor of SQL do you think many organizations use? Is it Microsoft? Is it Oracle? From your experience, which one is probably most popular?
Well, it's sounds funny, but you see, most times when I'm looking up jobs, I'm looking for .NET and Microsoft-related jobs. So it will be really difficult to tell. And I might be saying it from a point of bias, but I've actually seen a lot of companies use SQL, right? A lot of companies use Oracle too, but mostly people, because Oracle only recently, maybe a couple of years back, bought over Java and stuff like that. If not, before then, they didn't have a proprietary programming language. But for Microsoft, you get the full package. So a lot of companies tend to use Microsoft tools, because you get C#, you get Visual Studio, you get some of these tools that you can build an end-to-end application. So it just makes sense to, work with a SQL Server database, because if I'm using C#, then I'll use SQL Server, the integration will be a little more seamless. So I think a lot of huge companies, and there's support. So companies use Python, companies use so many other things, but these are applications that are supported by a community of people. But Microsoft has put in a lot, and every day they keep on, building tools that will make the job easier for developers. So most companies prefer to go to where they can get, a one-stop shop to get an end-to-end solution, right? So I think that's a win for Microsoft SQL Server. And then companies like Oracle, they have suites. So most times Oracle runs on certain applications. Like the company I work now, they use something called PeopleSoft. It's an Oracle application, right? So they are selling both the application and the database. But for Microsoft, you can just get the database, you can build the application yourself. So it gives you that, flexibility, right? So I think a lot of companies use Microsoft SQL Server, yeah.
Thank you so much. The reason I asked that was, if one was going to, look into some sort of certification, what should one be looking at as a first step? So I think that sort of answers my question in that area. Then the second one, which is the final one.
I'm sorry, I did it.
Yes.
Just because we have a bit of a time constraint here, and there are a lot of other people raising their hands. If you can put your message in the chat, we might be able to cycle back to it once, we can get everyone to answer the question.
Yeah, fair enough.
Apologies. Yeah, can we have Kemi go, please? Take a go at your question, please.
Hi, Sesugh. Thank you so much for this section. It's very, very insightful. Thank you so much. Yeah, my question is in two parts. So the first one, I would like you to expatiate on the many-to-many relationship.
Okay.
I kind of find that a bit difficult to understand.
Okay.
And for many-to-many relationship, is it necessary that we have like a connecting table? The other one is for the get dates, the get date function.
Okay.
Do we need to select any field from the table if we are using the get dates function?
So
yeah, those are the two questions I have.
okay, so I'll start with the second, then I'll go back to the first, right? So for the get date function, it was just to make it easier that I use this is like a function that returns the default date, right? So the get date function is a function on its own. So you don't even need to use anything. All it does is it returns the current date and time on your computer, which is on your server.
Okay.
Yeah. So, but you can also use the year function on other date columns, right? In your database. Yeah, you can use the year function and all that on date time columns in your database.
Okay, thank you.
Yeah. Well, then the first question was about the relationship. So so this is it. I want you to look at it this way. I was in this scenario, right? We have a form, and I'm saying this person can have more than one address, or let's say you have a company, right? You have employees, and then you have projects, and you in your business rule, an employee can work on more than one project, right? So an employee can be part of project A and can be part of project B, and then the project in itself contains different employees. You get the concept? So project A has 4 employees working there, project B has 6 employees. But employee 1 is working in both projects. So if you look at that, it is difficult to create that relationship without having a table in the middle. Because how would you represent it in just one column? What will happen is you will now have duplicate records. Let's say in the customer table now we have address, right? You would either have to have the whole information of catering again, and then in the address column, you put the first address. Then you have the information of catering as another row, and then you have another address. In the second row, you have the address column. So it's going to create duplicates. Anytime you want to update something about catering, then you have to update those 2 records. It really won't work. That's why you have the join table. The join table only makes it possible for you to have that many-to-many relationship, more like. I don't know if I know it's quite a complicated concept to grab, but once you play around with it, believe me, you get it.
Okay, thank you very much. That makes sense.
Okay, you're welcome.
Okay, I think we have time for just one more question.
Hello?
So let's go with you, Andrew. Sesugh, is that okay if we take a couple more questions? I know that we have short our time.
Yeah, I'm available.
Okay, thank you. I just needed to confirm.
Yeah, I can take as many questions as we have time for.
Okay, so
Andrew.
Oh.
Yes.
Hi, Andrew.
Thank you so much, Sesugh, for going through this. So I'm a beginner with all of this. So for you going through all of this, I didn't feel as intimidated with all of the information you shared because they were detailed and you went with easy to understand words. So thank you so much for that. My question pretty much is there a specific expectation or a requirement for advanced proficiency in Excel to be able to use this platform or to even learn this platform?
Well, to be honest with you, I'm not very good with Excel because I actually had the opportunity to learn SQL first. They are not really related. So Excel has a data analysis parts that I learned about recently. Excel has something called DAX, data analysis expression. So where you can actually build models, build tables and relationships, just like you do in SQL. But they really don't have any relationship in terms of knowledge because Excel doesn't really use SQL, right? You have your Excel syntaxes that you use. And but generally you will find certain similarities, right? Like maybe if conditional statements and all that, which you can find in virtually every programming language. But Excel is a powerful tool on its own. But when it comes to handling a lot of data, Excel has limitations with handling a lot of data. Excel has limitations with normalizing data. Most times in Excel, when you need to do something, you do something like a VLOOKUP, and it consumes a lot of CPU resources. With SQL, it's a machine that is built for this. So most times you're able to, manipulate data easier, faster. SQL Server also has something called indexes on columns, like primary key columns. You can create indexes that enable you to be able to sort and filter data faster. So an index is like your textbook, right? At the back of your textbook, you have something like an index that enables you to look for keywords inside that book. So it's similar to what the databases have. They're more efficient. They're two different tools. They do about the same thing, but Excel is powerful on its own, I would say, yeah.
Okay, thank you so much. I hope, as Osita said, hopefully we get some more sessions for us beginners so we can take advantage of the learning opportunities here. Thank you so much.
It will be my pleasure.
Can we have Biodun go next?
Okay, thank you so much. I just finished my postgraduate certificate from Georgian College in Big Data Analytics. And I'm currently trying to see how I can break into the data engineering field. I just wanted to ask if you understand and can explain the concept of data lakes, because I see that, in a lot of the jobs I try to check out, and I've been trying to, get a grasp of that as Steve.
Actually, when I grow up, I actually want to be a data engineer too. I'm actually working towards this. And so, but what I realized with most of these things is the big buzzwords are used, right, to create those things. But the data lake is simply just a pool of data. So in software engineering and all that, a lot of data integration happens, right? So the data lake is more like a database, but it allows you to store data in different formats, semi-structured formats like JSON, XML, and it creates easy retrieval for some of this data. So for me, I don't think it's anything big. I'm not really gone in depth into it, but believe me, it's nothing. If for being a data analyst, you need SQL. There's no doubt about it.
Yes.
Then you also need to understand the forms of data integrations. If you actually have some knowledge of programming and Python, then it's going to give you an edge.
Programming wasn't too easy during the program, so I just managed to pass.
You will need it. It's easy. It's just time. Yeah.
Okay.
Yeah.
And then what can you advise? For someone who just went into that program and trying to get a job? I just completed that in April. How can we actually sell ourselves to employers as it is?
Yeah, so that's always the difficult part, right? I don't know why people keep looking for people with experience when there will be no opportunity. Then you need opportunity to actually build that experience.
Yes.
But the beautiful thing about IT and data is you can actually do a lot on your own, right? You can create portfolios. That's what most employers look for. Even if you don't have that work experience, you can come up with projects in your head and create those portfolios. So there's Microsoft has something called something I completed recently. So if you Google, you can see Microsoft has a learning path for data engineers, and it's free. It's a lot of material, but what they do is they give you free access to Microsoft Azure. You create a Microsoft Azure account and then you go through that course. I started that for the data engineer, but I actually didn't finish. Then because I was doing two at a time, and I was able to focus more on the software engineering part. So you can look up those kind of courses. They give you insights, they give you practical knowledge, because they have text you read, they have videos, they have quizzes. And while you do those things, you can actually come up with personal ideas and build, little projects to solve little problems. There's, I'm sure you're familiar with Kaggle, because you're
yes.
Data, yeah. So you can get some data and do those presentations. You have So you can have them as a portfolio in your resume. And believe me, people will call you even if you've not worked for any big company. You know, a portfolio is,
Okay.
Yeah.
Thank you so much.
Welcome.
Okay, I think that's all we can take right now. Thank you so much, Sesugh. I've thoroughly enjoyed the session. I'm sure everyone has done so. By virtue of the comments that I have seen in the chat, you actually did a great job. We learned a lot. I'm sure people increased their knowledge as well. And I'm just going to quickly hand over to Osita just to say 1 or 2 words. I know we all know it's NIPCA, what NIPCA is about, but I'll just hand it over to you, Osita, to maybe give a vote of thanks or say something.
Thank you so very much, George. Thanks for that wonderful moderation. Thank you. We've got like 4 more people raising up their hands. Sesugh,
I'm available.
Would you want to give them like one minute?
I'm available. There's no.
Okay. So since we have 4 people, so let's Josh, can you just go through those 4 people raising up their hands? Probably 1 minute or thereabouts.
I believe, is it Adedeji, Andrew, and Biodun, right?
Yes, that's correct. Or have they asked their questions?
They have asked. The only person that had was Koflax. They had 1 additional question. So.
Oh, okay. So Koflax, can you go with your question? Koflax, are you still there?
No, I think he wasn't the one who had.
I did ask already my question.
Oh, you've asked your question. Oh, okay, fantastic.
I
Okay,
forgot to lower my range. Sorry.
Oh, no wahala, no issues. Okay, fantastic. That means we are good. Thank you so very much, Sesugh. The professor himself, the prof. Nice. This was really impactful, no doubt about it. Very, very impactful. And one thing I can say for sure is the fact that it's really a fundamental course or fundamental area, you know, as a tech professional. Most of, like, you know, when I started SQL back in the years, I didn't even know that you did some things with First Logic, Sesugh.
Oh yeah, I did First Logic.
Are you serious? As an instructor there, or?
Yeah, as an instructor, yeah.
Wow, look at you. So you know Chima?
Chima Vincent Wanko.
Yeah. We are the one that started First Logic now.
Oh, really?
If you mention Chima to me, you will scream. Back in 2003, I was the head of training at the Obakran location in Ikeja.
Yeah, I went there a couple of times.
Yeah, I was the head of training. So that was when I started picking into SQL and all those kind of things. Yeah. No, really insightful session. Great to know as well that you went through First Logic. Nice one. We really appreciate you so very much. Thank you so much for everything you've done tonight. We really appreciate you. And of course, I know the community as well, participants, each and every one of them also appreciate you. Guys, can you, unmute yourself? Just give Sesugh a round of applause. A round of applause, wherever, or just give him tributes, whatever you want to do. Let's appreciate him.
Whoa. Thank you.
Bosa.
Let's appreciate him. Yeah. Thank you so very much. So the L&D team will connect with you in the next couple of days. You know, let's see how we're able to freshen out some strategy in respect to incubation program. Just like, the incubation program have really been very, very impactful for a lot of members in the community, from the Salesforce to ServiceNow to software engineering that we did. It helps to open up people's perspective, that kind of thing, because one of the guy that shared his testimony, an Indian, the guy went through the ServiceNow. I think most of you saw that on our LinkedIn page. Just checked out our LinkedIn on NIPCA. You see the testimony from this guy. It really touched me. When this guy, having a chat with him, he was like, hey, he never knew that he would be accepted in NIPCA because he's an Indian. But at the same time, he wanted a community where he can learn, because he was in a confused state. He doesn't even understand, in terms of how his career progression is going and stuff like that. But he found NIPCA, he was able to join. He went through the ServiceNow incubation program, and through there, he got the voucher and got certified as a ServiceNow system administrator. Right now, he has got his eyes on the developer track. From developer, he can begin to talk about architect. So he has got a clear career plan in front of him. That is really what most people want to see, especially in terms of career. Tech is huge, IT is big. But again, when we're able to break these things in different buckets, it helps people to conceptualize, to understand their different directions. So we really appreciate you tonight. And the next couple of days, we should be able to firm up a strategy on incubation so that especially the beginners, they will be able to, gain those fundamental knowledge that is really required, as they launch into the different ecosystem. And after the fundamental part, we could also have something on advanced SQL as well, right? And someone like the last guy that spoke, the data engineer, the big data guy. So at that point, you can also come in as well and chime in as well. A lot of folks we want to learn a couple of things in big data and all those kind of stuff. So thank you so very much. We really appreciate you guys. And it's some minutes to 10.